Example 2. 2 and 3 are both word problems involving two statements of equality. And the first one I want to bring to your attention, and because we're going to be seeing these happening, and usually when we see something about ratios, we start making a chart, right? Okay, here's what I want to warn you about. A chart can work on this, but it's a little bit challenging to create it because we don't have specific topics. The ratio of two numbers, first number, second number, might be my categories, right? Usually it's the ratio of pigs to goats or something like that. We put pigs and goats, and the total number of barnyard animals is that, you know, that kind of stuff. So, but when it starts talking just about an abstract ratio of two numbers, when you see this statement here, and the thing that their ratio is about is just two abstract numbers, it's easier just to treat it like a basic algebra problem. All right? If I create two numbers, x equals one number, and y equals the other number. Okay? There's nothing telling me those numbers should be the same number, so I'm going to assume they're different, so I'm going to treat them with different variables. Okay? A ratio of two numbers is just one number over the other. So these words here translate to this expression here. The word is makes an equal sign, and 3 to 4 is just a numerical ratio. So the ratio of two numbers we don't know, x over y, is equal to two numbers we do know, ratio 3 over 4. That's all that statement's saying. And then if I cross multiply it, I get 4x equals 3y. And then if I make that into everything on one side equals a number thing, I'm going to get 4x minus 3y equals 0. That's the easiest way to handle a ratio of two numbers problem. Create your ratio statement, cross multiply, and then get it down to everything on one side equal to usually 0. Alright? Statement 2. Their sum is 84. Whose sum is 84?
X and Y.
X and Y. The sum means to add, right? So x plus y equals 84. Alright? So I create two equations because I have two unknowns. Once I create two equations, now I have the elimination or substitution technique. In this case, elimination is much easier to use, right? X's, Y's, constants. I would multiply the bottom equation by 3. 3 times x is 3x. 3 times y is positive 3y. 3 times 84 is 252. Okay. Elimination is all about getting rid of something. You can see here that negative 3y and positive 3y being opposites are going to go away. So multiplication of 3 is successful. And again, this is what I wanted to happen. 3x and 252 are consequences. Make sure that when you modify anything, you modify everything in that equation. So 4x and 3x make 7x. Negative 3y plus 3y cancel. 0 plus 252 is 252. Divide both sides by 7. And we get x equals, let's see, 36. We know from the red equation that x and y add up to 84. So if x is 36, I'm going to get 36 plus y equals 84, which gets me y equals 48. Okay, this is not a setup problem like this to begin with, right? We've created this setup. We've created the variables x and y. So writing x equals 36 and y equals 48 is meaningful in this problem, so I'm going to write it like that. Okay? If the problem starts off like this and just says solve, you're supposed to be writing ordered pairs. Some of you aren't doing that in your homework. Okay? But if it's a word problem, I invented the letters x and y for this problem, so x equals 36, y equals 48 gets it done. Two facts here. Fact number 1, the ratio of the numbers is supposed to be 3 to 4. The ratio I set up was x over y, right? If I did 36 over 48 and reduce that fraction as much as possible by 12, right? 36 divided by 12 is 3, 48 divided by 12 is 4. The ratio reduces to 3/4. So the ratio is true. Some of the numbers are supposed to be 84. 36 and 48 add up to 84. Both facts happen with those two numbers. That's the easy way to check these answers. They're telling you two facts about it. Make sure the two facts are true. That verifies the two answers is correct.